I'm just going to modify my drawing now to talk about a scramjet. Supersonic combustion ramjet. Let's just make it more aerodynamic inside. Supersonic combustion means just that. The airflow does not slow down at all. Fuel gets injected in there, burnt. And out it goes. So, supersonic combustion engines are pie-in-the-sky stuff. They have not been even operated, I think they might have been operated military, but obviously they're not going to tell us. I did see something about a Russian rocket travelling at 6 times the speed of sound, 7 times the speed of sound in the last 12 months, which is a scramjet. Supersonic combustion. Problem we've got, when you set fire to something, it takes time for the flame to take. If you're travelling faster than the speed of sound, the air is travelling faster than the speed of sound inside the engine. So if the air's travelling faster than the speed of sound inside the engine, that flame, physically every time you try to light it, it just blows straight out. Does not work. So standard combustion of hydrocarbon fuels needs a pinned flame like the flame arresters I just wiped out, the flame holders that were just in the back of the ramjet to stop the flame from blowing out. Supersonic combustion ramjets don't use them. They're just physically, you're working, once again, speed of sound 3, probably 4 times the speed of sound to hit the minimum speed necessary to get them to work. So you need something else, like a rocket, to get the aircraft travelling fast enough. You can see why it's really taken off for commercial aircraft. Would you want to strap yourself on a rocket so you can strap yourself to a liquid fuel jet? Probably not. So, Mach 4 and above, massive speeds, massive speeds necessary. The fuel is not hydrocarbon based, it is rocket fuel. It is liquid oxygen and something else that explodes when the liquid oxygen hits it. So it's an incredibly dangerous, incredibly highly explosive, incredibly fast moving flame front. If the speed in there is travelling at Mach 3 inside the jet or Mach 2, the flame front needs to be travelling faster than the airflow through in order for the engine to work. So we're talking massive technical difficulty and high risk. But that is a scramjet. Supersonic combustion runs on powdered fuels, liquid oxygen, or incredibly potent reactants. That is a scramjet. Air hits it at Mach 4, goes through, might be Mach 2 in there, burns, blasts out the back, and just keeps on going. Scramjets.